All right, guys, pre-AP biology. I just wanted today to give you a little lecture, kind of a continuation of our notes last week on basic chemistry. We talked about a lot of topics like structure of an atom and atomic number and all that type of stuff, valence electrons, bonding, ionic and covalent bonding. And today I want to talk a little bit about water because water is kind of a really important um, compound that's found in living things. In fact, it's the most abundant compound found in living things. But it has some very interesting properties which have a lot to do with its own chemistry and also the bonding within the actual molecule itself. So I want to kind of get into that a little bit today. Um, this won't be too long, but I think it's kind of an important topic that you all need to kind of understand. So I want to kind of go back to last week, or at least in the previous lecture notes that I gave you. And I want to talk a little bit about the bonding that's in a water molecule. Last week I mentioned a hydrogen atom, which is, atomic number one, right? It has one valence electron. So there it is. Again, I'm kind of drawing with my finger here. And this other hydrogen, the same thing, right? He's got one little valence electron. So neither one of these hydrogen atoms are really happy because they want to have two, right? That first, orbital, that first energy level, it's not filled. So hydrogen is not really happy being the way that it is. It wants to gain another one. Now, oxygen, which has an atomic number of 8, remember, 2 electrons go in the first orbital, and then there's 6 that go in the second. Even though the second one can hold a maximum of 8, there's only 6 to put in there. So it has 6 valence electrons. So there's one, right? There's two. I'm just going to arrange them this way, and there's a reason why I do that, but don't worry so much about it. There's 4, there's the fifth one, and then there's the sixth one over here, okay? So oxygen has 6 valence electrons. Now, again, it's not very happy because it wants to have that full, outer shell, that full outer orbital, and it needs to gain 2 in order to do that, right? So we've got every atom here wants to gain. So none of them want to give up any electrons. So we talked about this last week. The best thing that they can do is they can share, right? So those 2 electrons get shared, and then these 2 electrons get shared. And if they do that, then everybody is kind of happy. Now, the thing about this sharing is it's not really equal. It's kind of like, let's say you and your friend had a pizza, and you slice it into 8 pieces. Now, it would be equal if you gave your friend 4 pieces and then you took 4 pieces, but it wouldn't be very equal if you ate 7 and your friend only had 1, right? It wouldn't be very equal that way. So we kind of have that type of sharing between oxygen and hydrogen. Oxygen is an extremely strong atom. So these electrons, which remember are negatively charged, they actually get pulled in this direction. The same thing down here. These electrons, even though they're being shared, they get pulled again towards the oxygen. So what ends up happening is the oxygen ends up becoming a little bit negative because of this. And then the hydrogen ends end up becoming a little bit positive because of this. Again, I'm drawing with my finger. I apologize. So this is what we call polarity. Polarity is caused when you have unequal sharing of these electrons. Again, it's kind of like sharing a pizza, but one person gets 7 slices and the other one gets 1. Think of the oxygen as the individual who's getting more pizza slices. So he's pulling those electrons slightly more towards it. So again, the oxygen ends up being negative, slightly negative, and then the hydrogen end up being slightly positive. So hopefully that makes a little bit of sense to you there. All right. Now, because that occurs, there's some interesting things that happen between hydrogen molecules, or I should say water molecules. So, for example, here's a water molecule here, right? So here's the oxygen. And again, it's got that negative charge because those electrons are being pulled more towards it. And that leaves these hydrogen ends a little bit positive. Well, here's another water molecule here, right? And we have the same thing, right? The oxygen end is a little bit negative and the hydrogen ends are a little bit positive. So what ends up happening is we get this attraction here, right? You guys know that opposites attract, right? So the positive end of one water is attracted to the negative end of another water molecule. And we get this bond that kind of forms. We call that a hydrogen bond. All right, hydrogen bonds are formed when you have two molecules that are polar, and then the positive of one attracts the negative end of the other one. So those hydrogen bonds are prevalent in water molecules. This is the reason why, for example, a spider can walk on water, right? Because that spider, there's not enough weight to it to break through the strength of those hydrogen bonds, and that creates what we call surface tension, on water. That's what that is. A couple of vocab terms I want to kind of introduce to you. The first one is called cohesion. Cohesion basically means that water kind of sticks to itself, right? Because again, we've got those water molecules that are attracted to each other. So this cohesiveness is what kind of gives water that property of surface tension. So again, the reason why a spider can walk on water is because the spider doesn't break that surface tension. It doesn't break that cohesiveness of those water molecules. Another term that I want you to kind of be familiar with is the term adhesion. So not only does water kind of stick to itself, but it also sticks to other substances. Water, believe it or not, is kind of a sticky substance. I mean, for example, here's like a champagne bottle, right? And that condensation kind of forms on the outside of it. But I mean that those water droplets are kind of sticking to the glass. And again, that has a lot to do with those properties of water that we talked about earlier. Solutions. Anytime we're talking about water, normally we don't really talk about water in a pure sense. Most of the time, water is mixed with something else. For example, I don't know, Gatorade, right? Gatorade is water that's mixed with other things, right? There's things that are mixed in that water. Um, I don't know, salt water, which makes up our oceans, right? It's water, but there are things that are kind of dissolved in that water. So these are what we call solutions. Now, anytime we have a solution, there's kind of two terms that we need to be familiar with. One of them is called a solvent, and the other one is called the other one's called a solute. The solvent is what does the dissolving. So, for example, in salt water, right, water is the solvent. The solute is what gets dissolved. So, like salt would be a solute. If you had, let's say, a glass of iced tea, right, and you put like a tea bag in it or something, you drop some sugar in it or whatever, the water would be the solvent. The tea and the sugar and all those other things that are dissolving in the water would all be individual solutes. All right, so these are two terms I want you to know, right? A solution is when a substance is dissolved in water. But again, we have these two terms, solvent and solute. All right. But again, I mean, I think those are pretty easy to understand. They're just vocab terms. Shouldn't be too difficult. The term suspension. This is kind of an interesting one. A suspension happens when materials don't dissolve in a substance. I think one of the better examples that I can give you is Italian salad dressing. Like if you took a bottle of Italian dressing and like shook it up, see all those things like floating around or they're suspended inside of it. That's a suspension. That means those materials are not dissolving in that liquid. So Italian salad dressing is a good example of a suspension. Blood Blood's actually a really good example of both a solution and a suspension. I mean, if you think about like your blood, think about things that are in your blood, right? There are substances that are just floating in your blood. Things like red blood cells, white blood cells. I mean, those things aren't dissolved in your blood; they're just suspended in your blood. In fact, your blood is mostly water. It's made of a substance called plasma. The plasma is mostly water. So you have these things kind of floating in your blood. Now, there are also things that are dissolved in your blood. I mean, for example, all the nutrients that we eat, things like, I don't know, proteins and, lipids, all these things that we eat, sugars, carbohydrates, vitamins, minerals, those things all dissolve into our bloodstream. So blood is kind of both a solution and a suspension. All right, guys, I'm going to stop here for today. Rewatch this video if you need to. There's some good vocabulary terms there, and make sure that we understand that term polarity. That's kind of a big vocab term. All right, guys, have a good day.